Hi everyone, my name is Edward. I'm your UGTA for the Circuit 3 class, and today we are going to talk about the introduction of BodePlot. So it's basically how you can draw the BodePlot for the magnitude and phase plot after you see a transfer function. So first, I think it's very important to understand the standardized form of a transfer function, which means every time you see a transfer function, you want to make sure that it is in this form. It's written in this form. Otherwise, you can't really draw the BodePlots. So if we look closer to this standardized form, first the transfer function name, it's h of j omega, which can also be written as h of s. And we have a it's a constant, which will be very useful later to determine where is the starting point when you draw the magnitude plots. And then on top, we have 0. In the bottom, it means poles. What it means by 0 and poles, I will give a very clear example down below, so you'll be able to understand that. So let's use an example that a professor used in class. So I would say step 1 is to standardize the transfer function, and then step 2, find the poles and zeros from the transfer function. So let's say if the transfer function is given to be 20s, in the bottom is s over 5 plus 1 and s over 500 plus 1. So right now, if you compare this transfer function and the standardized transfer function, you realize that it's written in the same form, so we do not have to change this. Later on, I will do another example which we will have to change it. So right now, we will be able to find the following things. A, it's equal to 20. So A is this constant here, which is 20. And then for the 0, we will set up the top function, which is 20s, to 0. You try to solve for s, so it's gonna be equal to 0. It means that there is a 0 when s is equal to 0. And for pole, we set up the function to equal to 0 and solve for s, so s is equal to -5. And same thing for the next pole, s over 500 plus 1, set it up equal to 0, solve for s is equal to -500. So one thing to be aware of is, even though we have, let's say for the pole, we have two poles, right? Even though pole s is equal to -5 and s is equal to -500, actually we don't really care at this point if they're negative or not, because ultimately when we are plotting the magnitude plot, we will take the absolute value, the magnitude of the transfer function. So we only care about the positive values here. So then step 3, it's to find the starting point. For the magnitude plot. So we notice that A, it's equal to 20. You want to apply that into the following equation: 20 log base 10 A, which is equal to 20 log base 10 20, which is equal to 26.02. So I would say 26 dB. So this values here, it's the starting point. You will see that soon. So let me actually highlight this in, let's say, green. So then we can go to the next step, which is drawing the plots. So I have so first of all, I have a rules here that you have to follow before you draw the BodePlots. So first of all, you want to make sure that if you have a 0, you have a positive 20 dB slope for the magnitude, and for pole, you have a negative 20 slope. For phase, you have a positive 90 degree and 45 degree per deck, and negative 90 degree for poles, and it's gonna be negative 45 degree per deck. And if you have a 0 at origin, then you have a 20 dB at omega equal to 1. If you have a pole at origin, then you have negative 20 dB at omega equal to 1. So let me try to visualize that for you in the plots with this rules given on top here. So let's see. So I've already drawn this. So let's see. So right now, so we notice that from our transfer function, we have so starting point for the magnitude response, it's equal to 26 dB. We have a 0 at 0. We have a pole s equal to 5 and s equal to 500. So and then so let's go. So right now we said that we have a s equal to 0, right? What does it mean? It means we have a 0 at origin. And we said this before, if we have a 0 at origin, we will have to have a positive 20 dB, right? At omega equal to 1. So we notice that right away at so by the way, our starting point is 26 dB. That's why we begin, let's say here, 26 dB. This is gonna be our starting point. And we notice that we have a 0 at origin. So at omega equal to 1, which is this values, right? Omega equal to 1, you notice that you will have a positive 20 dB. So then until, let's say, until 5, then you decide what's gonna happen next. So what's happened at 5? At 5, we have a pole, right? So we notice that if we got a pole, s equal to 5, at a pole, we have a negative 20 dB. So when we draw that, so at 5, let's say we want to draw a negative 20 dB, but realize that at this point, this is a positive 20 dB, and we have a negative 20 dB at 5, that means it will cancel out until the next pole or 0 that you meet, which is at s equal to 500. So the red highlighter that I have here represent the pole or 0 that we actually have from the transfer function. So this one here, it's plus 20 dB from the previous 0 at origin, minus 20 dB from the pole, which is equal to 0. That's why we have a flat line. And then at s equal to 500, we have another pole. That's why we're gonna minus 20 dB. And at this point, we are going to minus 20 dB. Because we do not have a positive 20 dB previously. So we do not cancel it out. So we will have a negative 20 dB. So that's pretty much it for the magnitude plots. So let's look at the phase plots. So for the phase plot, we do the same thing again. But now we notice that if we have 0 at origin, I will use purple. A 0 at origin will have positive 90 degree. That's why at this point, let's say 90 degree, you will have a straight line. But that's not the final answer because you have 2 more 0, right? At 5 and at 500. So what you want to do, it's say 45 degree. Let's say this is 0, and then you have 45 degree negative and negative 90 degree. So we can actually first put the points and then we line up. So we notice that we have a pole at 5 and a pole at 500. Therefore, for pole, we notice that it's gonna be minus 9 degree, and it will be minus 35 degree per deck. That means we're starting at 90 degree here. This is our starting point, and then we're gonna minus 9 degree by every 45 degree. So that means at 5, it's gonna be, there's a point here, and there is a point here. So minus 45 degree and minus 45 degree. So this whole thing right now, it's minus 90 degree. And then at 500, we notice that we have another pole. So we are going to minus 90 degree again, and it's gonna be minus 45 degree per deck. So from 0 until minus 90, we put 500 at the point of negative 45 degree. And then you will be minus 25 degree and minus another 45 degree again. And then you draw the line flat. So this is how you draw the face. Let me make it in red. It might be easier to see. And yeah, this is how I think of drawing face and magnitude plots. So basically, I will just go through this again real quick. Basically, you want to find the standardized form first. Find A, find your pose and 0, and then find your starting point with respect to A, and then follow the rules I have here. So since you have already find your pose and 0, right? So you can basically know, like, if you have a 0, if you have a pole, what you should be doing in the magnitude and phase plots. Then make sure you also understand that if you have a positive line previously and it's like positive 20, and let's say right now you have another pole, so you're doing minus 20, then positive 20 plus minus 20 will give you a flat line. Let's say you have a positive 40, and then you have a pole, so you're doing minus 20, right? So that means you won't have a flat line, but you have a positive 20, because positive 40 minus 20. So your line, the next line might look like this, and this will become plus 20. And I also mentioned before where I will work on an example to show you how to standardize a transfer function. So let's say if this is the transfer function that given, and going back to our standardized form, I'll just copy and paste real quick. So this is our standardized form. And obviously you will be able to see these two forms are different because we have a 10 here, we have a 100 here, which is different than we have a 1 here and we have a 1 here. So what you really want to do is just apply math. So it will be equal to 10. You take out 10 and 100. Over 100 plus j omega over 100. On top it's gonna be 100, 1 plus j omega. So then when you cancel out 1, 1. So what you left will be 1 plus j omega over 10. So you can put this 10 on top, it will be 1 over 10, which is A. In the bottom, you got 1 plus j omega over 10, 1 plus j omega over 100. So right now, this will be the same as the standardized form. And you will be able to figure it out. A is equal to 1 over 10. You have a 0 as at s equal to minus 1. You have a pole as at s equal to minus 10, as equal to minus 100. Yep. So right now, you might be realized, why do I write negative here? So actually, it's negative, but once you go to BodePlot, it doesn't really matter, because you only drawing the positive side, because in terms of magnitude, you always look at the absolute values, right? Therefore, it's gonna be positive anyway. So that's pretty much it, and thank you for listening.